In our system of derivation, there are two rules that are about the contradiction, the symbol with the two lines, one perpendicular to the other. The first rule is this one. It says that if you have derived a contradiction at some point in your derivation, then in the next line you can write any formula you like. In this case, we write the formula psi, but you can write any formula you like. This rule formalizes the idea that once you have arrived at a contradiction, you can say anything you want. So it's good to avoid arriving at a contradiction, because otherwise your claims become meaningless, because anything follows from the contradiction. This is what is formalized by this rule. The other rule for the contradiction is that if you have assumed the negation of some formula phi at some point, and then through certain steps in your derivation you arrived at a contradiction, then in the next line you can write your formula phi. And you can cancel your assumption not phi. This rule formalizes the idea of a proof by contradiction. So the proof by contradiction proceeds by assuming the negation of a certain formula, deriving a contradiction from that assumption, and then asserting the formula that was initially negated. The expression RAA abbreviates the Latin expression of reductio ad absurdum, which is the same as saying proof by contradiction. It is important that you do not confuse the rule of reductio ad absurdum, or proof by contradiction, that we have just seen, RAA, with the rule for implication introduction, although the two rules are in some respects similar, but they are also different. So here are two examples of the rule of implication introduction. In the first example, we start with we assume the formula phi, and then we derive a contradiction. What the rule for implication introduction allows us to do at this point is to write the negation of phi. This is because our notational convention, according to which phi implies the contradiction, is the same as the negation of phi. The application of the rule for implication introduction that you see on in the middle is slightly different. So it begins with assuming the negation of phi, and then again derives the contradiction. This is another hypothetical case that we are considering. And what the rule for implication introduction allows us to do at this point is to derive the negation of the negation of phi. So these two are examples of how we can use the rule for implication introduction when we are dealing with contradiction and negation. But do not confuse these uses of implication introduction with the rule RAA, or reductio ad absurdum, or proof by contradiction. On the right-hand side, you see an application of the rule of reductio ad absurdum. So we start with the assumption not phi, we arrive at the contradiction, and we can then derive the formula phi itself. So going from the negation of phi to phi itself is not obvious. In some sense, what the rule of reductio ad absurdum codifies or formalizes is the idea that we use sometimes when we talk, and we say that two negations make up an assertion. And if you say not, this is equivalent to asserting the content that is subject to this double negation. So what the rule of reductio ad absurdum formalizes is this idea that a double negation makes an assertion. However, this is a controversial idea, and some mathematicians and logicians do not accept it. So it's important to keep in mind the peculiarity of the rule of reductio ad absurdum.